Hey guys, welcome back. In today's video, I'm going to be discussing equivalence relations. So an equivalence relation, this is the sign of it, on a set X, is an equivalence relation if it's reflexive, symmetric, and transitive. So if you want to know what reflexive, symmetric, and transitive means, I've made a video on binary relations as well, so make sure to check that out and I'll explain what these three are. So let's look at an example where you have to prove whether something is an equivalence relation or not. Let's define a relation where this is the symbol. It's defined on this with x1 comma x2 is equal to y1 comma y2, or not equal, the relation, if and only if x1 is equal to y1. So if you have a pair of integers, like an integer tuple, they're considered this symbol right here, if their first terms are equal. So let's try to prove that this is an equivalence relation. So we have to first show that it's reflexive. I'm just going to write an R. So we have to show that x r x. That's what being reflexive is. So is x1 comma x2 is this true? It is, because x1 is equal to x1. We just look at the first terms. The first terms are equal, so it is reflexive. So we have proved that. Now let's look at symmetric. So you have to show for all x1 comma x2 and y1 comma y2 in our domain, if x1 comma x2 and y1 comma y2 share this relation, then x1 is equal to y1. By the symmetry of equality, y1 is equal to x1, meaning y1 comma y2 and x1 comma x2 are related by this relation. So it is symmetric. Now let's look at transitive. For all x1 comma x2, y1 comma y2 and z1 comma z2, if x1 comma x2 and y1 comma y2 follow this relation, this means that x1 is equal to y1. Just writing that as a side note. Then, or and, y1 comma y2 and z1 comma z2 follow the relation. This means that y1 is equal to z1. So therefore, by transitivity, x1 is equal to z1, which means x1 comma x2 and z1 comma z2 follow this relation. So we have proved that it's reflexive, symmetric, and transitive. Therefore, it is an equivalence relation. Thank you so much, and I hope you enjoyed today's video.